wishes to enclose a rectangular region. He has 120 feet of fencing and plans to use the barn as one side of the enclosure. Let X represent the length of one of the parallel sides of the fencing. So the one on your homework, you were putting fence around all sides. Okay, this one's a little bit different because how many sides are we actually building for our fence? Just 3 sides. So I would recommend starting with a picture here. So we know we have a rectangular region. This time I'm only asking for 3 sides, but I could ask for 4. I said X is the length of the parallel sides. So these are X's. We know in a rectangle opposite sides are the same. Do I know how long this one is? Well, 120 is the whole thing when I put all 3 together. So we're going to use that. I don't know what this is. Let's call it y for a moment. We know we don't really want an equation with x and y in it. So we have to figure out what y might represent. We kind of did that yesterday. We had a problem where it said like the sum of 2 numbers was 33. And we said, okay, the numbers were x and y. X plus y equals 33. And we solved for y. If we have 120 feet of fence, that's like the perimeter. So that's saying if I add these things together, x plus y plus x, it has to equal 101.
20 minus 2x.
So that missing side is 120 minus 2x. So now I know my rectangle has lengths of x and 120 minus 2x. I am asking you to find the area. How do we do area of a rectangle? That's a triangle. Mm-hmm. So my area is my length times my width. And you could say 120x minus 2x squared. So we had to do a few things on that. We had to figure out what our sides represented using the 120, and then we had to find our area, length times width. Any questions about part A? Part B. What is the maximum area that can be enclosed? Anytime I ask you for a max or min, what am I asking you to find? Vertex. How do we find a vertex? Okay. What's my B value? The opposite of 120 over 2 times A, which is 2.
Then we have to put that into the equation, do we?
Right. I want the maximum area. I found x, so now we plug that into our area formula. Our max area is 1,800. We were in feet, square feet. I also asked you what dimensions. So that's length times width. I know that one side is 30, so 30 feet by, how do I find the other side?
Just 1,800 divided.
That would work, because it's length times width.
Minus 2.
Or you can use the picture, the 120 minus 2 times 30. So we get 60. So it's, the fence is 30 feet by 60 feet. The area is 1,800 square feet. Just make sure at the end that you are answering all questions that were asked. Questions there? Alright, I want you guys to read this one and see if you can answer some of these questions. We have an equation here. It tells us that this is the equation for height. T is the time, so if I say after 2 seconds, 2 is the time, all we're doing is plugging that in to see what we get for our height. 4.9 times 2 squared plus 73.5 times 2. So that's all we're doing, plugging that into our equation. And what'd you get? What would my label be? Meters. Told us up here the height in meters was given by this. Okay, B, what's the maximum? If I'm asking you to find a maximum or minimum, what am I asking you to do? Vertex. So opposite of B, so negative 73.5 over 2 times A. And what do you get? 7.5? Is that my height? No. That's how long. So we hit our maximum after 7.5 seconds. How do I actually find the height? Plug it in. And we get the maximum height of? Okay. C, how long will it take to return to the ground? If it's on the ground, what's our height?
0.
0. So we're plugging in 0 for the height. What could I take out of this?
T.
A t at the very least.
So that's your 0 that you're starting with.
Okay, so I get 2 times. T equals 0 is because this thing started on the ground. At time 0, it was on the ground. And then you threw it, it hit its high point, and it came back down. So then the 15 seconds is when it comes back to the ground.
Couldn't you also just multiply your vertex times 2 because your vertex is at the dead top and center of the parabola?
That works as long as you threw it from the ground. If it were something where you were, if I were standing on top of the table and I threw it up, it will not simply just be double. So it only works if you start on the ground, throw it up, and it comes back. Other questions?
calculations for imperfect parabolas?
Mm-hmm.
So like, cause if you threw a ball straight up, it would not actually do a perfect parabola and.
Yes, we can manipulate different parts of it. We're just using the simplified
Well,
vertical
we're
motion.
learning right now.
Right, yes, but those do exist. Other questions? Okay. We're going to do just a few more problems. I maybe want to do one or two more today. We are going to go ahead and work on this tomorrow as well. I think the word problems are a little bit harder. So we're going to do a couple more today. We'll do some tomorrow as well. I want you guys to see if you can draw a picture and label everything to start this problem. Let's make sure the first part of the picture is right, and then I'm going to have you try to label the sides. We have a boat. I've seen some beautiful boats. You guys are very artistic. So here's my boat. Okay, it is being pulled into a dock with a rope attached to the boat at water level. So I've got my water here, the boat in the water. How does the dock sit? Does the dock sit under the water? Right, docks are going to sit above the water. Okay, I have a rope going from the boat at water level to the dock. What shape am I forming right here? So we're talking about a right triangle here. See if you can read the information and label the sides of that triangle. When the boat is 12 feet from the dock, which side of the triangle measures how far the boat is from the dock?
The bottom.
The bottom. And I just told you that's 12. The length of the rope from the boat to the dock, where's the rope?
The top.
The hypotenuse, is 3 feet longer than, so that means we're adding 3, twice the height of the dock above water. Do I know how tall the dock is? So x, so twice that would be 2x. So now I have my triangle labeled. If we have a right triangle, what do we know?
A squared plus b squared plus c squared.
Okay, so x squared plus 12 squared equals 2x plus 3 squared. Okay, to square this, you have to write it twice in FOIL. So we get 4x squared plus 6x plus 6x plus 9. Quadratics, what do we set those equal to? 0, so if I subtract over my x squared, I have 3x squared plus 12x. Subtract over your 144, you get alright. I need to solve this. Do you notice anything about it? We can divide everything by 3. You can either factor out the 3 or it's an equation. We could divide both sides. Okay, what multiplies to negative 45 and adds to positive 4? So the x would be 5 and negative 9. Are both answers reasonable? No, because what does x represent? Yeah, it was the height of the dock above water. So we couldn't have a negative height. So the dock is 5 feet above water. on that one? Final problem of the day, and then you guys get time to work on homework. Similar to one we have already done today. A fence will be built around a new playground. The school will be used for one side of the fence. So, what do we know?
It's pretty good.
We're only doing 3 sides. Now, does that mean every time I give you one of these problems it'll involve 3 sides? No. The one on the homework involves 4 sides, so you do have to pay attention to that. So I know that I am purchasing 250 meters of fence. What does the 250 represent? The perimeter. Okay, so for a moment, let's just call these X and Y. Opposite sides are equal. If you had all 4 sides, the top one would be labeled Y as well. So I know that when I add all of these, it's going to equal 250. I'm trying to solve for Y because I don't want 2 variables, so my missing side is 250 minus 2x. Alright, from there, what am I trying to find? I need x to give me the maximum area. So if I'm going to find the biggest possible area, I need an equation for area. How do you find area of a rectangle? Okay, so for us, that's x times, instead of y, we use 250 minus 2x. Our area is 250x minus 2x squared. Anytime I ask you to find maximum or minimum, what are we finding? Vertex. How do we find vertex? So opposite of b would be a negative 250 over 2 times negative 2. And what do we get? Alright. So, to find my maximum area, I plug that into the area formula. My units, this was meters, area is always squared. So that's my maximum area. The other thing I asked was what dimensions should be used. So the fence should be and my x is 62.5 meters. To find my y, plug that in here. 250 minus 2 times 62.5, and we get are there questions on that? So you guys have the rest of the hour to work on that handout from yesterday. It is due tomorrow, so we'll do a few more problems tomorrow.